This is about accelerating your Oracle and mainframe modernization journey. And this is the agenda where we'll start about the strategy and why customers are choosing to do this. Then we will talk about the specific success stories where we have successfully migrated these customers in collaboration, working very closely with them. And then we will go into the demos, and then we will take any Q&A from there. Sometimes a picture is worth 1,000 words. And this shouldn't come as a surprise to any one of you. If you look at the investments that the companies are making in their data portfolio and the data lakes, it is very evident in terms of what is the value a data can bring to an enterprise. And if you look at any app, and if you look at how much data is stored, the data side is growing exponentially. And obviously, the reason is very, very simple. These days, you can extract so much information and insight from the data. And like if you look at all the innovations on the AI, on co-pilots, everything is based on the data that an enterprise has collected. Even the entire concept of the large language model is based on how much data you can scan, and based on that, you can drive the intelligence. So similarly, if you go back 10, 15 years, and if you look at any app which was written on any of the databases, the companies were storing very, very simple data, which was coming from the user interaction. But nowadays, every click, every location, everything is stored, because all of that can be correlated with the rest of the portfolio for that individual customer or the set of the customer, and that helps you drive more insights and eventually grow your businesses. So, which also means that you have to be on a platform where you know that the companies are actively investing in driving new capabilities and innovation. Otherwise, if you are sitting on a system which was built a long time back, maybe is secure and deliver your current improvements, but your progression will slow down because you won't be able to innovate on top of that. And that is one of the reasons, like many of the companies are thinking of getting off of the mainframes and even Oracle and trying to find products that are at the cutting edge of the innovation. And for Microsoft, in order to go and help these customers win, there are 3 investments that we make. The first one is about, obviously, our own service has to be ready to take these workloads, which are either coming from the mainframe or from Oracle. And these some of these services you are already familiar with, whether it is on the hyperscale, whether it is on the managed instance, SQLDB, or even the VMs. The other part of the same first point is that even if we have those services ready, we need to also ease the journey. And easing the journey starts from what tools we provide you to go into this migration. Once that is there, the second thing is that typically these are more complicated and involved exercises as compared to an homogeneous migration where the source and the destination is the same engine, which means that, that we need to be involved in these migrations with you. And this is honestly the biggest difference that it makes. And it doesn't mean that if you are migrating a lot of the systems, every time the same level of involvement is needed. But we come in, we assess, we lower the friction which is there. We fully understand not all of our services, but your system as well. And the journey becomes possible. And once we have shown the success, then you can follow on that success. And the third thing is that as we come and do these migration projects with you, in the process, obviously, we learn a lot. Not only we learn a lot, we also enhance our products, and we build specific IP that can be reused over time. It can be reused in your next project. It can be reused with other customers who are trying to take the same journey. So these three steps we are investing, and it makes the end-to-end journey really, really easy, and the chances of the success goes up significantly. These are some of the recent examples where we have successfully migrated either from the mainframe to SQL or from Oracle. And obviously, if you double click on each and one of these stories, and we are happy to do that sitting with you, it will tell you a very rich story in terms of how we made them successful. And not only about the journey, but once they landed on SQL, how they were able to modernize at a much, much faster pace than where they were stuck on the earlier systems. I will just talk about two, and then I will let Mukesh and Des come in and go into the details. The first is the ABN AMRO. They moved from the Oracle one, right? They went from the Oracle one, and if you look at the details, whether it is for this one or any of the other customers we will talk about, it will be a very, very similar story. It talks about the TCO. Typically, they get a huge, huge advantage in terms of when they are running on the SQL, many times up to, in their case, up to $1 million. The pace of the innovation, as I talked about, improves a lot because now they are a system which is continuously be invested. And obviously, the supportability and the reliability that Azure brings, and the enterprise readiness that you get for your application. And altogether, this is what helps them truly innovate their app stack. The second one which I want to talk about is the legal and general. And in this case also, as I mentioned, the journey started by saying that we are sitting on a system which is not being invested, and we need to go and get on the SQL. And this journey itself, we also learned a lot in the process. And in many of these cases, you will go all the way and see how we have even improved the SQL side of the things. Even the investment that we are making in the type system for the SQL or the regex work that is going on, it is helping us improve the migrations that are coming further down the road, because then the parity mismatch is not there in terms of the mainframes or the Oracle side of the thing and the SQL side of the things. So these are some of the ones which we have recently completed. And I will invite Mukesh and Des to come and talk in more detail in terms of what was the actual work that went into these ones and in other cases.
Thank you, Asad. Thank you, Asad. Perfect. So, Asad talked about some of the investments and couple of case studies briefly, but the name itself should explain, right, the complexities at which we have really white-gloved engaged with these customers, right? And the complexities were not just one folding, right? Like they definitely had technical parity problem. They also had functional parity concerns. They also had bunch of non-functional parity concerns. And there are a couple of examples that I will take into slightly deeper as part of this talk track. But before I do that, for this community who is very hyper-focused on converting SQL business, growing SQL business, right? I do want to make sure that you understand and you have confidence in Microsoft ecosystem, that Microsoft ecosystem is really thinking deep into how do you go and have these conversations with mainframe line of business and Oracle line of business, because reality is they don't use the same language most of the time, right? Their terms, their use cases are not exactly same as we see in, let's say, .NETs of the world or distributed x86 of the world, right? And to do that, tying back to Asad's investments strategy that he talked about, we have really been laser focused on addressing whether it's Oracle or mainframe, one-time initial data movement, one-time or initial data load use cases. How do we simplify that process, right? Same goes for data streaming, near real-time sync, CDC, whether it's unidirectional or bidirectional. By the way, we are still not listing the app and middleware use cases here. This is purely focused on data because that's the the audience here. But once you know that these are the use cases that you'll be challenged, right? What we have done is we have focused our investment. For example, one time or initial, you will often be challenged. Okay, I got DB2, or I got Oracle, or I got Oracle RAC or Exadata, right? I do need to move massive schema sets, pools of schema. I have massive data as part of initial data load. I do need to do data streaming, right? How does Microsoft tools stack and really correlate to solving that problem? And let's face it, not every SQL sellers or solution provider is today equipped to go answer that question. And what we are trying from Microsoft side is to really dumb down that problem statement and templatize enough so that you can go and have that level-headed conversation with line of businesses or central IT of these large enterprises who really can afford to run Oracle and mainframe, right? And this metrics briefly explains some of those correlation and how this ties back to our tooling. And our tooling is not restricted to just first-party tooling. We do have a massive third-party ISV and solution providers ecosystem who are joining us, maturing with us, engagement by engagement. For example, many of you might already know SSMA, SQL Server Migration Assistant. Many of you might have used ADF, but did you ever attempt to really generalize the usage of these tools like ADF in the context of Oracle and mainframe modernization? Some of you might have done. I see a few faces who are already doing it, right, in their enterprises, but not the mass public, right? And we want to make sure that you understand ADF and SSMA or stream analytics for data streaming is not restricted just for x86. There are a bunch of S500, Fortune 500 customers who are doing data streaming using stream analytics, right, away from mainframe and Oracle. Some of the third party, if I can call out, like Stream and Click, Golden Gate, which I'm sure many of you already know, IBM Golden Gate. It's not restricted just for Oracle, right? Golden Gate does a phenomenal job to coexist between DB2 and SQL, or DB2 to Oracle and then SQL. There are multiple use cases, right, that it helps us with. Now, next, this slide briefly just outlines the not complete, but some of the leading ISV and third-party ecosystem that we are currently very actively working with, right? Whether some of the logos that you saw in Asad's talk track, including Legal & General and ABN AMRO, right? There are very large names that we can't really talk about at this stage, but all of these folks are really collaborating with Microsoft to make those enterprises data-first transformation successful. Few to name, for example, Click, right? Stream. These ISVs are really solving us with change data capture and online data movement use cases, because there are so many layers of complications that prohibit us not to have first-party capability to really do online data movement. This is where exactly this Click or Stream type of systems are filling that gap. And there is an engineering level innovation going. There are engagements-specific collaboration that we are doing and learning from it, and really publishing it on Azure.com. If you go to Azure.com modernization solution page, you will find a bunch of these details and reusable IPs and reference architectures. Before I move to next one, I do want to call out a couple of names in the mainframe side, like OpenText, earlier known as Micro Focus. OpenText has acquired Micro Focus. And then Raincode. Like Raincode is a classic one where we did engineering R&D collaboration, and 6 months ago they went to market. They launched a GTM around IMS to IAM-SQL. Just imagine, I mean, who would have thought hierarchical database coming to relational, and that too with an efficiency to match mainframe perf, to match mainframe speed, right? The conversion of batch mode to singleton. Happy to inform, we have achieved those. There are a bunch of customers who have moved their mission critical from IMS and DB2 as a combination to SQL. So again, this slide really talks about what we have learned, right, some of the top of the funnel problems, challenges, right, that enterprises are facing. Some of the problems are really common challenge, right? Nothing specific to mainframe or Oracle. For example, discovery and assessment, it's an easy use case, but the most complex one. If you don't handle this properly, there are a lot of back and forth and a lot of CapEx and OpEx, I would say inflation happens in actual expenditure, right? Target state architecture, online data migration with minimal downtime, as I talked about, stream and click use cases, that really fits into that bucket. How do we deal with complex data type and schema migrations? Like Asad talked about some of the trim and data type and built-in functions enhancements that we have shipped in SQL 2022. That is precisely to address this area, right? Because I'll just take an example. Often in applications, things like trim, things like date add, right? Average, some of these data type and built-in functions are used so frequently that if you don't have parity at engine level and you are trying to use either a third-party or first-party tool to do C-type conversions, it adds to latency. And when you are dealing with milliseconds of latency, moving away from mainframe to x86, it matters. Same goes for Oracle. Hence, we have taken a very conscious decision to slowly bridge this gap directly at engine level. We are not there yet, but we are making good progress on that front. Now, if you go to Oracle specific, I'm sure many of these are on top of your mind, right? Complex PL SQL, your Pro-C, rigidness at the application layer or data application layer, your zero data loss recovery appliance, like that's a salience capability. How do you solve that on Azure side, on SQL side, right? Same goes for mainframe. Very basic, as if how do you really sustain ABSTIC to ASCII conversion, right? One of the most frequent one that we see is how do we maintain security claims, directory claims, which is stored in RACF in directory stores, right? And then a bunch of other things like scheduler and how do we really re-engineer some of the, like the hierarchical database to RDBMS example I took. That's a frequent challenge that we are seeing with these large customers. Now, we can't, again, name customer because this is too much of a detail, but if I can tie back to some of the wins, right, that Asad just talked, if you see a common theme around many of those customers for Oracle migration, the complexities were like top 4 were as is listed, right? These were mission critical apps. They needed to build a migration pattern because everybody on the line of business side and the sustain or the operation side was concerned that can we pull this through? So they wanted to have a minimum viable product, MVP, shipped, right, with our help. And then all of them were really hard pressed with aggressive cutover because these are system of records. They can't afford to have any even planned downtime for longer. So most of these projects really were warranted to have a coexistence model. And that's why, like I was earlier talking about Golden Gate efficiency and others, while they are complete products for us, it also helped us stay in coexistence and then cut over, then really rely on the first-party tools and services. And then if you see the solution, right, one of the value prop that Microsoft Azure and Azure SQL platform ended up giving these customers is we gave them a lot of choices. When their workloads qualified for SQL as a platform, guess what? They're not just restricted to SQL on-prem or SQL on VM. They now have a scale-out architecture-based hyperscale. They have more granular controlled SQL managed instance, right? If they are modularizing enough and going into hyper-burst model, they have elastic pools offering, right? So, and they were amazed to see, especially these line of businesses who are always given one problem, one solution, never multiple solutions. And they were amazed to see the amount of solutions and choices Microsoft and SQL product and Azure platform could give them, like workload by workload. Similarly for mainframe, right? almost same model, same problem statement. But one more thing I want to call out, right? Like we often talk about TCO, ROI optimization, new business functionality enhancements, but a new learning that we are getting from all these engagements is that their security teams are very scared of cyber attacks, right? Despite of being in Oracle and IBM mainframe or any other mainframe versions that you can think of, they are scared of cyber attacks, and they need to do innovation at multiple layers, tiers, come to x86 so they can have better protection across the layers. Nobody talks about it, right? But that's another pressing reasons that we are seeing customers are taking these bold steps, making investment and moving away from Oracle and IBM. Now, having said this, while we are tapping into this market, making gradual progress, but each and every progress is like very heavy, right? It's effort-wise, the product capability-wise, but of course also from ROI-wise, right? Despite of having all those things said, we do realize, right, the salient capabilities that Oracle and IBM brings on table, and why customers are still staying there, right? Why it's very hard to let go of these systems and implementations. Despite of all the limitations, customers are still maintaining it, right? And what we have done is just listed like top 7 to 8, right? Like if your application requires high availability, disaster recovery, multi-region right? You know Oracle and IBM are giving you the best. Today, if the line of businesses are presented with this challenge, they are not looking elsewhere unless they are educated enough, they are pursued enough by the industry experts like yourself, right? That, hey, you don't have to go that expensive path. Microsoft and SQL does have an option for you, right? Those folks are not thinking otherwise, right? So what we have tried to do on this slide is really show you a quick picture of how does high availability that Oracle rack, right, or the OHAS, or the IBM Tivoli-based or DB2 pacemaker-based type of scale of high availability, how is that achieved, right? So for example, while they have robust system, none of those systems have guaranteed SLA. Unless somebody owns the app outsourcing and SLO definitions in Oracle or IBM environment, they can't guarantee. Azure and SQL guarantees out of box, right? List goes on. If I go, it will take like 1 hour just going through each of these items. But I do want to make sure that you understand when these tough conversations are presented to you, be rest assured you are backed up. You have enough collaterals now on Azure.com Architecture Center around mainframe and Oracle modernization where you can leverage and bootstrap these engagements. And if in doubt, if you need help, please reach out. Please reach out to your closest Microsoft colleague, friends, and engage us. We are more than happy to help you. And with that, let me hand it over to Des for a quick demo.
Hello? Where is that going? Okay. All right. Thank you, Mukesh. Thanks for handing over. And now let's hope that the demos work. So, and actually they should do because I've recorded them, so I'll be speaking through the recordings. So I'm pretty sure they're going to work. Before we get into the demos, though, just to set kind of some of the stage for what I'm going to be showing here. We heard earlier from Asad and Mukesh both about the importance of heterogeneous migration to Azure and the investments and the key investments we're making in first-party tools and as well as our ISV partners who are listed for both Oracle and Mainframe. Generally speaking, we see high prevalence of those tools and solutions being used in the modernization journey of our customers. However, there are always outliers, as was mentioned by Mukesh. And for that reason, in the engineering team, we sometimes have to come up with some innovative kind of solutions around bridging some of the gaps until we bring those features natively into our first-party tools. And there can be other reasons as well why customers are looking for individual solutions. Perhaps they don't want to enter into an agreement with one of those ISVs that was seen previously, or they just feel that it isn't giving them the performance that they require. So for that reason, we've come up with a number of IPs, and today I'll show 2 of those IPs, which are basically solutions from our side to bridge specific gaps like I mentioned before. The first of these is around the high-performance data migration using Spark. So we've heard from a number of customers that they want to be able to move data both offline initially as well as continuously to Azure Data Services from existing Oracle environments. And they need to do that in a performant manner with as quick a transfer of data as possible. So one of the solutions that we've come up with to do that is this data migration process that we run in using Spark in the Spark engine on Scala and execute to give us kind of the performance that those customers need. So I'm going to start here by showing basically our environment, which is currently Oracle Database 11g Express Edition, which is like our own SQL Server Express Edition, basically the XE edition. Just to do a quick count to show the row count, we've got 50 million rows in this table, in this employees table on the Oracle side. And those 50 million rows we're going to be moving over into the SQL Server environment. And just to show that there's no smoke and mirrors, we're going to do a count from the SQL side and see that, hey presto, we've got 0 rows. And now we're going to go and have a look at how this magic happens. We're going to first go and have a look at the compute that we've created, the cluster we've created. In this case, Databricks. It can also be Fabric SQL pools. We're showing the Databricks runtime version, and here the size of the worker nodes and the current min and max. We're showing the libraries we've installed. If we need to install additional libraries, we can go to the Maven repository or any repository, pull down those libraries. Currently, we have the connectivity libraries for connecting to SQL and Oracle, as well as an XML library, because we use XML to move the data. Now, when we go into workspaces, we can have a look at our Databricks notebook. And within here, you can see that we're importing our libraries and the various Scala libraries that are needed. We're making a connection to the source, to our Oracle source. In this case, we're telling it to use a total of 32 partitions for the move. That's to parallelize the data movement, make it faster. And then we're going to connect to our SQL environment. And just showing the connectivity here, we're using SQL Auth, but of course we could also use here Entra or Windows authentication as well. Then we're going to go and show that in this example, we're not going to be moving the full schema, so all of the HR schema, which is the test schema in Oracle across. Rather, we're just going to be taking this one table, this employees big table. This is nice as well because you can select individual tables, objects, and even columns that you want to move using this IP. And we're going to move it across from the HR schema in Oracle over into our DBO schema in the SQL environment. So we're now going to go down and start our actual process, our Scala job, and get that kicked off. And what we're going to see is it's starting up. So it's going to start up by dividing up that large table into the 32 partitions. It's going to basically start the process in parallel. So we see here 3 of those 32 partitions have been moved. We're about a minute into the process. I'll be skipping forward in this demo as well, just for a matter of time. But you'll see here that we've already processed 3 of the 32 partitions. 8 are currently running. If we look at the compute node, we'll note that the cluster itself and the workers hasn't actually expanded yet. It will, don't worry. That's what we're doing this for, is to show that you can have kind of, in a way, limitless movement. This is for 50 million rows. You may need to change this if you're doing more data than that. We go back in and have a look at our job, see how it's progressing. And we'll see here that the job is basically has now processed 6 partitions in 1 minute 52 seconds. We've got 8 running in parallel, and out of the total 32. We'll finally go in here as well, just to have a look to see. Now we can see that we have 6 worker nodes have been spun up. So we've got increased by 2. We don't catch it in the demo here, but it actually does go all the way up to the maximum that we've provisioned very quickly and then ramps down again. Here we'll see that we have 12 of our partitions are done, 20 are left running. So basically it's in its final stages here. If we would go back, we would have seen there that it was ramped up to the full 8 worker nodes. And now finally, again, skipping forward, and maybe a little bit difficult to see, but 13 minutes and 45 seconds or so. What we've seen is around, for this, we can reproduce with these sizes 50 million rows in that test control environment in about like it says here, 14 minutes. So again, you're going to have a little bit of variance in this, and just showing here that it actually has moved the data. So we're going to see here that it's got 50 million rows in the SQL Server side. What we often get asked, though, I'll just leave this running, is this is one test table, right, that we're using, kind of a controlled environment. In a more general term, what can we push using this Spark IP? We have real world and multiple examples of where we've been able to move about, in terms of data volume, about 1 terabyte every 2.25 hours. So from Oracle into SQL Server. And we've been able to reproduce that with, you know, pretty much linearly. We can improve performance throughout. So just from a pure data movement perspective, those are the kind of volumes of data that we're able to push through using this kind of setup. And again, that, by the way, just to be very open and transparent, that value of 1 terabyte every, say, 2.25 hours is Azure to Azure. So if the environment is currently an Oracle database on Azure, running an IaaS, for example, and we're moving to Azure SQL Database Hyperscale, for example, then those are the kind of numbers that we can see. If you're running from on-premises and moving to Azure, clearly there's other influencing factors, like primarily network, that are going to have a big influence on that. So keep that in mind, like with ExpressRoute and whatever bandwidth you have with ExpressRoute and exclusivity of usage and the like. So that's showing one part, right? That's showing moving the data. So how do I get my data from Oracle over into SQL as quickly and efficiently as possible, and you know, at a kind of a high rate? But what our customers are also demanding is, of course, well, once I have my data over, how can I be absolutely sure, apart from that you showed a lovely select count, how can I be sure, and primarily as well with like mainframe data, DB2 data as well, how can I be absolutely certain that it isn't only a row count that's matching, but the actual data is the same, right? That there hasn't been a kind of a problem with a, you know, decimal point in the wrong place, or loss of kind of precision on a numeric value, for example, right? So what we've done there is we've created, we've created another utility, which is called Database Compare Utility. We're going to show it here in action with DB2, but actually we support a whole range of sources for the database compare utility. So, you know, pretty much, you know, you can actually do SQL to SQL as well, but you can do Oracle, DB2, both LUW and ZOS. You can do MySQL, Maria, Postgres. So basically it's very open in terms of if you're doing your data migration from any of those sources into SQL or PostgreSQL, you can use this tool to do data validation after the migration. So let me just start this. So here, what we're seeing is basically I'm showing, and I know it's very small, I apologize for that, but you have to trust me here. It's DB2 LUW and it's SQL, and it's a local instance of SQL Server here, SQL Server 2022. Just showing the download utility and where you can, the database compare utility can be gotten from our downloads repository. So if you type it into a search engine of your choice, database compare utility, this is where it'll bring you to download it. The latest version is 2.4.6. It's a brand new version. We released it just at the beginning of this month. And you can go ahead and download it. In the interest of time, I'll just move a little bit forward here. Oops, sorry. I shouldn't have done that. It doesn't like that. No, it doesn't like that. So in trying to save time, I've now cost myself time. But in essence, what this does is that it basically builds up a MD5 hash of the rows in both the source and target, and then it does an evaluation of the same hash value basically across those rows. Now I can imagine some people might be thinking, hey, that sounds great, but it sounds like it might take a lot of time and it might cost a lot of resources to build those kind of hashes. And the answer is yes, it does. So you would not be using this if you were, pretty confident of the data conformity after your migration. But it is something that, like, for very important data sets, where we've seen this highly used is in the financial services industry, where they need to be sure that those kind of issues that I talked about earlier, like numeric values and precision, are maintained post-migration. This can be a very helpful tool to do that, like I mentioned. So here it's basically just extracting the database compare utility locally onto the local machine. Once that's complete, basically this tool is just very self-explanatory. It's well documented because the config that we're opening up now, and you will see yourselves, is quite complicated. There's quite a lot of variables and options that need to be set. So this is something to keep in mind as well, that it's well documented. It may look complex here. The tool itself is quite complex, but the good news is everything is documented. So what we're doing here basically is that we're going to remove, because we have no need for the source that was currently in there, which was for Postgres. We're making sure that it's only going to be looking at DB2, LUW, and comparing it for SQL. And what we're doing here is making the connection to the target, which is SQL, of course, with trusted authentication. And then we're going to be coming down further in the configuration file and uncommenting out basically the section for DB2LUW. And you can see underneath is DB2ZOS, and there's all the different sources that I mentioned before, right, are in there. And they have their own configurations because there can be variances between data types clearly in each of those relational databases. Here we're just changing the user ID and making the connection with the hashed password. So we also provide a utility to hash passwords so that you don't have to put plain text passwords in if you need to share this, right? Now we're going to run the database compare utility itself, and it opens up the console application. Anything yellow is a warning, anything red is bad news, right? But there's no red here, which is good. Again, a reason I recorded and didn't do a live demo. But the yellow is basically just showing us where we're having mismatches, okay? And where there are warnings, so where those hashes aren't matching. To get more information, we can go in, because every time that we produce that for a table, we basically create a log file. So you can go into the log file and you can get detailed information as to what the actual mismatch was. And in this case, you can see that there was 2 mismatches, okay, on 2 rows. So one of the rows had a mismatch because of the name was spelled Saunders and Saunders, so with an E and not an A. And the other one was because there was a change in a difference in the job and in the years. Okay, 7 and 8. So this is just a demo, right? But it's just showing basically that the tool highlights this in a log file for you to be able to go and have a look at it. What we also do is we produce an Excel file. So an Excel file is also produced, which uses a nice handy just color to let you know in all those areas where there's been variances found. So differences between the MD5 hash. Okay, let me go here. I mentioned before that we have a number of IPs, and these are our top kind of trending IPs. We can look at what the trend is of IP utilization. These are the kind of top, 8 IPs spread across Oracle and Mainframe for modernization. We have a lot of IP as well around SQL to SQL and just SQL best practice from our engineering team. So, I'm not going to go through each one of these line by line, but these can be extremely helpful in Mainframe and Oracle DB2 modernizations. And with that, I'm complete from my side. And if there's a question, please let me know.
So is that source controlled, or is it just an executable you can download?
The database compare utility?
Yeah, we find it easier if we can go get it and build it ourselves than trying to get the exe.
Okay. So you can't get the exe for it because we control the source for the actual code. But we can work certainly with you. The developer who's working on this is, very open to hearing what you might want to add to it, or how you think that we could improve it.
It's just trying to get it in the business takes months.
So like whitelisting it.
Yeah.
Ah, okay.
If we seen the code, it would go through our scanners and it would just get approved quicker.
Yeah, we've heard that a couple of times. These processes can take some time to, basically whitelist or curate these services, and that can take some time. No, unfortunately, it's proprietary, but again, we're willing to work, and if there's a way we can work together to help you get it curated, then that's something that we'd be more than open to do. And again, all of this, including the database compare utility, as I mentioned before, these are custom IPs because we in the SQL engineering group, we have to build them right now. The idea in the future is, of course, to implement these directly into first-party tooling that we already have.
Yeah. So in near future, we are about to start migrating larger scale Oracle clients to SQL Server in Azure, VM in IS. Some background about that we discussed. Now, is there any checklist kind of thing from Ninja team that before engaging you guys, we can go through that how to understand Oracle workload and understand what all are the prerequisites we should be checking and have enough due diligence in place?
So yes, we have certainly some IPs, and I'll let Mukesh come in here just after me. We have certainly some helpful IPs that can give you insight, for example, on workload assessment, so that you can look at your workload assessment, get an understanding for what are the right questions to go to your line of business applications with, to understand what the profile of those LOB or COTS, like commercial off-the-shelf apps are, and then basically based on that, make a judgment, back to Mukesh's points on saliency and features, what would be the right path, the right migration path, and ultimately the proper target for those workloads.
Yeah, if I can add, so there are multiple layers to even catalog those questions and help you with disposition for the target, right? Also find out, is it worth really modernizing or rehosting, or just do the lift and shift, right? So those layers of assessment models do exist. Please reach out to us. There are a few startup I would say jumpstart you can get from database migration, Microsoft Docs as well. But reach out to us. We have enough curated models that are being used by all Big Four consulting firms and many of the FSI customers. We are more than happy to share that with you under existing NDA and EULA. Unfortunately, these are something we can't publish. There are legal ramifications.
I see. Yeah.
Right? But we can work with you under existing EULA.
Okay. Sounds good. Thank you.
Always.
Okay.
Any
other questions from anybody? Okay, whoops. Otherwise, we'll start our song and we'll let you get out. Thanks very much, everybody. Thanks for joining. Good luck with those migrations.